Enterprise technology is crossing a threshold. We're moving from passive generative models, chatbots waiting for prompts, to autonomous agents that independently drive real-world workflows. Giving these systems the power to act introduces a serious liability. Many agents currently operate with a volatile, temporary memory. They can perform intricate coding or scheduling operations, but because their logic is confined to a short-term session, they are prone to sudden hallucinations. They lose the thread of the larger goal and forget their own previous actions within minutes. This creates the trust gap. When agents are deployed without a central management layer, they become zombies running in the background of a network. This unchecked shadow AI creates vulnerabilities like zero-click attacks, where an agent is manipulated into executing commands or exposing data without a human ever realizing a session was active. This graphic demonstrates the shift. On the left, early AI models were probabilistic and opaque. Enterprise-ready architecture must transition to deterministic frameworks like Anven. For critical infrastructure, unmanaged cloud agents are a risk, requiring sovereign systems with total data governance and zero telemetry exfiltration. Bridging the trust gap requires a change in how AI retains information. By 2026, the industry is moving away from stateless sessions toward near-infinite context windows. This allows a model to hold hundreds of thousands of data points in its active thinking space, providing perfect historical recall across long timelines. Multimodal RAG, or Retrieval Augmented Generation, serves as the secure index for this memory. It processes an enterprise's entire operational history, including complex spreadsheets, secure code repositories, and visual assets, to give the AI a living map of the business. This architecture allows engineers to enforce strict grounding. Instead of guessing when it encounters a gap in its knowledge, the model is restricted to the proprietary database. If the factual answer isn't in your secure data, the model is strictly programmed to refuse the prompt. When raw data is successfully bridged to this infinite, grounded context, the technology matures. The AI functions as a continuous, reliable digital worker rather than a temporary tool. Model development has diverged toward the opposite ends of the computational spectrum. On the high end, we see 50 trillion parameter behemoths like the Treecapital AI series. These models require massive compute stacks because they are engineered for ultra-long context processing, designed to synthesize entire legal archives or decades of engineering blueprints in a single pass. At the other extreme is the intelligence at the edge movement. Here, models are refined into optimized 3 billion parameter reasoning engines that run locally on hardware with minimal power. This chart shows how quantization technology achieves that efficiency. By mathematically compressing the model's internal weights, we reduce the hardware memory overhead by 75%. This allows the AI to retain its structural logic while requiring a fraction of the storage space. This diagram illustrates that efficiency. On the left, the Anven AI quantized node routes directly into edge devices and embedded software, operating with near-zero latency. On the right, the Anven 1.1 model extends to multimodal tasks, providing visual identification capabilities for field operations. For complex workflows, the industry is moving away from the super agent that tries to do everything, shifting instead toward multi-agent orchestration. An orchestrator parses a goal and assigns it to specialists. A planner agent maps steps, a coder executes the script, and a critic verifies the result. This creates a verification loop where agents cross-check each other to catch errors. This coordination requires an agent operating system. This blueprint shows how the operating layer enforces identity, manages memory, and keeps agents in sandboxes. It turns organic chaos into a structured cognition matrix, applying strict guardrails to target 95% reasoning accuracy. Scalable autonomy is only possible when an orchestrating layer acts as the ultimate supervisor for the digital workforce. This orchestration layer is now moving beyond digital screens and into physical space. By utilizing world foundation models that simulate physical laws, like gravity and friction, agents can now be trained to govern heavy industrial assets and automated factory workflows. In a physical environment, the latency of a cloud-based API isn't just a software delay, it is a physical risk. If a robotic arm or an energy grid relies on a rented model that suffers a 500 millisecond spike or an unannounced update, The result is a collision or a system failure. This graphic illustrates the solution, Sovereign AI. It's an intelligence layer behind your firewall, fortifying the chaotic flow of proprietary data into a secure 3D digital asset. Running locally bakes industry logic into the model weights, turning your data into a permanent, private advantage. In the autonomous age, generic AI is a liability you rent, but sovereign AI is a digital asset you own. The Anven ecosystem bridges your raw data to production-ready enterprise AI, ensuring your intelligence remains fully under your control.